Ever wondered who can actually see your data in Power BI? Spoiler alert, it's not as private as you might think unless you master row-level security. In this episode, we don't just check the RLS box, we break down the moving parts from role definitions to the DAX expressions that quietly decide who sees what. Most people stop at setup, but we're going to show you how every decision connects, so your data isn't just locked, it's architected for security. Why row-level security is a system, not a checkbox. If you're used to locking down a sensitive spreadsheet by slapping a password on it, you already know there's a gap between what you intend and what actually protects your data. Power BI with row-level security can feel exactly the same. You hit the RLS toggle, assign a couple of roles, and think we're covered. But the reality is different. Sensitive data finds a way out when those connections between roles, filters, and users aren't carefully mapped. People rarely talk about the times when someone on the sales team opened up a dashboard and ended up with a clear view into numbers they never should have seen. But it happens, and it almost always starts with the assumption that RLS is just one more box to check during setup. Let's put you in the shoes of someone who's handed out dashboard access thinking you're just empowering a colleague. Feels harmless, right? But in too many organizations, access to one dashboard is access to everything behind the scenes. I've seen environments where a single global manager role accidentally allowed junior users to browse confidential HR data just because the naming didn't match reality. This isn't a rare one-off either. It's closer to the rule than the exception, especially when a company is growing and dashboards are multiplying. Everyone wants to move fast, but when you move without structure, tiny holes get left behind that can turn into gaping gaps during an audit. On paper, RLS couldn't sound simpler. Build a role, maybe call it sales, add a filter like region, Excel US, and map users to it. But behind every dropdown and checkbox in Power BI, there's a system making decisions about what data travels where. If you miss one relationship or a filter doesn't capture a new data source, it isn't just a technical slip, it's a security incident waiting to happen. You won't know until someone stumbles over data they aren't supposed to see, and sometimes not even then. That's what makes these little misses so hard to catch. They don't come with warning bells, and standard audits often don't drill deep enough to notice them. What gets overlooked is how tightly connected RLS components actually are. Most tutorials breeze through setup, walking you through role creation and filter basics. They'll demonstrate mapping users and checking a preview box. But next to nobody pauses to interrogate how a filter on the sales table affects, say, a related territories table. Every bit of logic in RLS ripples into the others, assignments, DAX expressions, and even the naming of the roles themselves. Treat those choices as isolated steps, and you're trusting the system not to have any loose ends. But one forgotten filter, and suddenly your careful role setup is like a sieve. This is one of those areas where the right analogy isn't a locked door. It's a mesh of threads. You change one part, the whole thing can subtly shift. Miss a thread and you've created a leak that isn't even obvious until it's exploited. Actual incidents show how this plays out. Insider stories from analytics teams talk about the moment when the European sales lead stumbled onto data from North America's pipeline. That wasn't someone breaking in, it was a misapplied filter, an unintentional default, or a role that nobody thought to double check. It's not just real-world horror stories either. Microsoft's own vulnerability reports list misconfigured row-level security as one of the top reasons for embarrassing public data exposure in large organizations. For every news headline about a big breach, there are dozens that go unreported but have lasting consequences behind the scenes. What ties these problems together is the false sense of security RLS offers when you treat it like a simple item to cross off a to-do list. Studies from Microsoft security teams underscore that layering filters, stacking them across tables, applying additional DAX expressions, or using combinations of static and dynamic logic ramps up both protection and complexity. Each layer you add doesn't just make things safer. It multiplies the number of points where a configuration mistake can occur. Instead of a simple gatekeeper at the door, you've got a complex web where one missed node can undermine months of security planning. Let's not glaze over the practical realities either. A system might work fine in test, but drag it into production with real users, real departments, and ever-shifting teams, and you get situations where someone who changed teams last quarter still has access to the quarterly finance numbers. Names and assignments that made sense early on turn into mysterious legacy artifacts nobody wants to touch just in case they're still being used. If you're only toggling RLS at setup and moving on, you're not protecting your data. You're hoping nobody comes knocking at the wrong door, whether through curiosity or mistake. All this leads to one core truth: row-level security is alive. It shifts with your organization. Every role you build, every DAX filter you apply, every group you assign, these aren't small choices. They flow together to create a living, breathing system of protection, or if ignored, a mesh full of holes. So before you move on to the next dashboard or hand off a model, pause and ask, am I actually managing a security system or just hoping the switch is enough? The next part of this story starts with the piece at the heart of it all, the filter logic itself and how it steers every other decision you make. Building a secure foundation, data filtering, and role design. If you've ever set up row-level security thinking it was just about keeping certain rows out of view, you're not alone. The main reason RLS gets messy is one simple misunderstanding. This isn't just about what's visible, it's about shaping the entire user experience. One quick misstep and suddenly that confidential bonus table or executive salary figure spills over into someone's dashboard. But people discover these leaks when reports are already in circulation, and by that point, backtracking can get awkward. The uncomfortable part, these breakdowns rarely look dramatic. It's usually some edge case, a US manager logs in and sees just what they're supposed to, but a London colleague opens the same model and without anyone realizing it, finds New York's number sitting right there. Think about kicking off a fabric model for global sales. You want managers in different regions to see only their own data. The reflex is to drop in a filter, something simple. Region equal US or country equal UK. But here's the catch. How you write that filter and how you hook it into your model decides whether your system actually holds together or comes apart the minute things get more complex. Plenty of folks assume it's dead simple, a one-line DAX filter, and then move on. But not all DAX behaves the same way. In fact, those nuances often break things later, especially when you move from Power BI desktop over to Fabric, where cloud-level quirks start to surface. RLS gets tangled pretty quickly when you get into the weeds. People often bank on functions like username or user principal name, guessing they do the same thing or just grabbing whichever one a blog post uses. But swap username, which pulls your Windows name in desktop, for user principal name, which grabs your email address in Fabric, and suddenly your filter logic starts to wobble. If you've ever had a test work in desktop but collapse once you publish to Fabric, this is probably why. And picking wrong? That's how gaps open up, quietly giving the wrong people a window into data they should never touch. Let's get specific. For basic scenarios, a hard-coded check works. Region equal US means only rows where the region is US show up. That's textbook static RLS. It's quick, it's simple, and for fixed divisions like a report meant only for US managers, it gets the job done. But as soon as someone asks for dynamic security, things shift. You might need to determine access based not just on the report viewer, but on relationships in another table. A user access table, for example, listing which users see which regions. Now, your RLS filter isn't just a fixed value, it's a formula that looks up what regions each person should access in real time. Here's where DAX can trip you up if you're not careful. You might reach for something like user principal name and then try to join it to your access table. But if your DAX relies on calculated columns or pulls in logic that doesn't respond to the user context at view time, you can accidentally break the dynamic filter. Real-world example, a company sets up a dynamic filter relying on a calculated column in their fact table, only to realize later that calculated columns are evaluated when data is loaded, not when it's viewed. This means users can't see their personalized rows, or worse, see too much. You don't notice until a user pings you asking why a report looks different for them than for someone else on the same team. Microsoft's documentation and a long parade of MVP blog posts keep shouting from the rooftops. Don't trust calculated columns with RLS. Calculated columns are locked at refresh. They don't change by user. For RLS to actually respond to the viewer, your filter logic needs to be built as a DAX expression on tables that update in the report context. Ignore this, and your dashboards quietly betray you, showing the same rows no matter who's logged in. Static versus dynamic RLS isn't just a technical distinction, it's about when and how data is filtered. A static RLS is fast and rigid, great for when you know exactly which role needs what data ahead of time. If you're launching a report with just a finance or sales group, this works. But go dynamic, and every access decision happens on the fly, usually by matching current user identity to an entry in a lookup table of permissions. The flexibility is powerful, especially for big organizations or multi-tenant deployments. But every step up in flexibility adds complexity, and complexity always carries hidden risk. Even advanced admins get tripped up believing filters are always straightforward. The actual shape of your organization changes constantly, and your DAX filters have to keep up. Many break because they don't realize how RLS logic gets applied, not during data load, but every time a user interacts with a report. Forget that, and you can accidentally open up or block off whole sections of your data model without realizing it. The bottom line: get the foundation wrong, and nothing else you build with RLS will matter. The way you write your DAX, the kind of filters you use, and where you apply them, these pile together to shape your real security posture. Skip the nuance, and you end up with a setup that works in theory but leaks in practice. All this happens before you even get to mapping users to roles, which turns out to be the next place things quietly go sideways. Mapping roles to users, the assignment trap. So you've set up your roles, crafted the filters, and things look tight on the model side. The next step, assigning users, sounds like a no-brainer, but here's where most row-level security plans quietly start to crack. This is the crossroads of IT thinking. The technical logic is in place, but now you're betting that the human layer, your user and group assignments, actually matches the reality of how your business runs. It looks simple because there's a group field and a list of roles, but experience says this is where mistakes like to hide. Picture this: you've created a manager role, dropped your carefully built filter onto it, and mapped the role in Power BI or Fabric to an Azure AD group called managers. You double check, maybe even get a second set of eyes on it, and roll it out to the org. At first, it feels straightforward. That's kind of the problem, because group logic, especially in big organizations, rarely stays simple for long. Teams shift, departments reorganize, roles evolve, people leave one project to join another. What happens if someone moves from sales to operations and no one prunes the old group memberships? Suddenly, your airtight RLS blueprint has a user in two places at once, and there's a real risk they get access to data that's no longer theirs. It's easy to assume that everyone in a particular Azure AD group should get the same access. But in reality, group memberships can grow stale. Someone might transfer to a different region, but their name never leaves the original team list. Even if you, as the admin, are pretty disciplined about cleaning up, group owners rarely keep up with every shuffle, especially during a busy quarter. And remember, the sync between Azure AD and Power BI or Fabric isn't always instant. Sometimes it lags by hours, and that's more than enough time for someone to see something they shouldn't after a change. Wait for an overnight batch, and a departing employee can leave with a lot more context than you intended. Shadow assignments might sound dramatic, but they're almost routine. In most real-world environments, a single user can easily end up in multiple groups, each mapped to different RLS roles. The design is meant to be flexible, which is good in theory. In practice, it means you're juggling a web of inherited permissions, and it's not always clear who can see what unless you manually chase it down. For example, if Sarah from finance moves to HR and nobody pulls her out of the finance group, she's now wearing two hats, one current, one outdated. Most people don't even notice until Sarah herself tries to access a report meant for finance and still gets right in long after she's gone to a different department. Microsoft's own security teams call out role assignment errors as the number one cause of accidental data exposure in analytics environments. The math is simple. The more groups and the more shifting users, the easier it is to overlook who's actually attached to each role. What makes it sneakier is the lack of obvious feedback. Unlike other security mistakes, you don't get an error message or a break in the UI. There's usually no automated warning or forced review, and incorrect mapping can sit in the shadows for months, surfacing only during an audit or when someone stumbles onto data they weren't meant to touch. Even the best intentions get whittled away by day-to-day realities. Reviewing group memberships is a best practice that everyone recommends, but few teams actually follow with any rigor. From the admin side, it's tedious work. Manual group reviews aren't exactly a top-of-mind priority, especially if the analytics team is firefighting other issues. And in most organizations, there isn't a process set up for regular audits because it's assumed that changes in HR or IT will trickle through. But assumptions are exactly what let permissions drift and shadow access persist. The result, over time, your RLS model, no matter how precise on paper, gets out of sync with who should really see what. Automated auditing tools can help spot these lingering assignments, but getting them stood up takes work. They need to connect your Azure AD, flag changes, maybe even trigger a workflow when someone's group memberships don't match their business unit anymore. Not every Power BI environment has those kinds of checks in place, especially smaller shops or projects run off tight deadlines. So, group sprawl becomes inevitable. The longer your RLS system sits, the more likely it is that permissions go stale or worse, cascade into different layers you're not even tracking. What really catches people off guard is that assignments aren't just a check mark. They're the continuous link that binds your security logic to real people. Leave them to drift, and all the clever DAX in the world won't save you. Assignment hygiene is an active process, not a one and done setup. Systems evolve, users move. Your model has to track those changes, or you're left relying on luck. And luck isn't a security strategy. Now, even with the tightest assignment processes, a major curveball comes the moment you take your carefully built solution from Power BI desktop into the wild fabric. Up until this point, most teams are testing in the local sandbox on their own machine with only test accounts. Things feel predictable, but move to Fabric and all sorts of subtle differences in user context, group resolution, and authentication timing begin to show up. That's where we run into the quirks nobody expects, and why assignments that seem perfect in theory can break spectacularly in production. From desktop to Fabric, the hidden shifts in RLS behavior. If you've ever been convinced you had row-level security completely under control in Power BI desktop, but then watched everything unravel the moment you published to Fabric, you're in familiar territory. This is the part nobody tells you about in RLS tutorials, the moment where all that flawless role and filter logic runs headlong into the reality of the cloud. You've checked every filter, carefully mapped every group, and even tidied up those edge case assignments. But the second you move to the Fabric service, things shift in a way that catches even seasoned admins off guard. Let's start with what you see in desktop. The preview works just like you'd expect. You test user roles, you toggle between sample identities, everything lines up perfectly, the numbers match, and for a moment it feels like you've nailed a straightforward process. But as soon as your teammates start opening that same Power BI file in the cloud, the stories start rolling in. Somebody reports seeing numbers outside of their region, or worse, someone's locked out of a dataset they absolutely need to do their job. The frustration grows when you realize the same RLS setup that was watertight on your machine now acts more like a suggestion than a rule. That confusion comes down to differences you can't actually see until you publish. Fabric's cloud environment operates in a different world when it comes to security, identity, and data context. One classic gotcha hits right at the heart of dynamic RLS patterns. In desktop, a DAX function like username pulls your local Windows login. Simple, predictable, and inside your environment reassuringly stable. But on Fabric, that same username call grabs your full email address instead. It sounds minor, but if your filter or lookup references domain names, or if your security table keys off short formats versus full emails, the entire system breaks down the moment users hit the cloud. Inevitably, you start running into complaints. Here's what happens in real environments. A report shows a country breakdown in desktop, but after publish, users see global numbers. Maybe your model relied on user principal name because all your access keys are email addresses. That's good practice for cloud, but if you started out in desktop and didn't know this shift happens, you're debugging a problem that doesn't exist locally but explodes at scale. The truth is, what works on your laptop is more of a decent prototype than a finished solution. Local logic can hide a landmine that only cloud authentication triggers. There are also a few invisible levers Fabric pulls without warning. Data refreshes, for one, can fire off with different credentials or land on a different model owner than you expected. If the published dataset's owner isn't in the right group, they can end up seeing no data at all or getting access to everything by accident. Changing ownership in the cloud doesn't just affect permissions, it can break connections to gateways or change how credentials are evaluated against source systems. Sometimes tenant settings hide legacy behavior or default to options that override what you set up during desktop testing. For organizations with layered tenant policies, something as small as toggling external sharing can shift the logic of who sees what overnight. What throws people is how subtle these changes are. They don't shout, "Hey, your RLS is broken now." Instead, things operate quietly wrong. A small change in authentication or the way a model resolves group membership during sign-in mutates security context entirely. Microsoft's support forums are packed with admins trading horror stories about reports that passed every desktop test, only to fall apart once users started accessing them in the cloud. You see threads where, after a rollout, teams are scrambling to patch or redesign all their RLS roles, not because the logic was bad, but because the move to Fabric shifted the identity context enough to make everything unreliable. Even cloud upgrades or tenant-wide updates can nudge security in new directions. Sometimes after an update, group mappings managed by Azure ID Sync just a little differently than before, so that shadow assignments suddenly have more priority or certain dynamic lookups run into nulls where you expected a match. Small changes add up. A tweak in one piece of the stack ripples through the whole security mesh, and your most reliable pattern from last quarter just doesn't hold up today. That's why real-world teams have started to treat RLS testing as a production job, not just a local check. It's not enough to click through roles on your own laptop. You need to actually stage the model in Fabric, bring in real user accounts, and walk through the end-to-end permission flow. Only then do you catch subtle authentication bugs or misalignments between group assignments and what Power BI thinks is current in Azure AD. Some organizations even script out periodic RLS audits in the cloud just to check for drift between assignment, model logic, and what Fabric actually enforces. There's no shortcut here. If you're not testing with real people in the environment where your report truly lives, your RLS is basically running on hope. The cloud is the final referee, and the only way to see how filters and roles interact with identities at scale is to build your RLS with production in mind from the start. If you leave these tests for later, you're flying blind, and the consequences expose data, frustrated teams, or careful security work undone by a hidden switch wind up costing far more to fix once the report's in use. Now, facing this landscape, the big question isn't just about patching up your RLS each time something shifts. It's about whether you have a plan that works as your Fabric setup gets more complicated, your data grows, and the business keeps changing. Every gap you find in cloud testing is a signal to rethink, not just patch, the blueprint for scalable, reliable, row-level security moving forward. That's not a one-time job, but an ongoing part of managing analytics at any real scale. And as Fabric gets integrated deeper into how organizations manage and share data, missing this cloud-driven piece of RLS logic is where most mature deployments trip themselves up. Every time you update a role, tweak a filter, or shuffle user groups, you're working with a system that never sits still. RLS isn't just a one-time project. It's ongoing architecture that needs real maintenance. Anyone treating it like a checkbox is on borrowed time and hoping nothing changes, but everything does. If you want Power BI models that actually stay secure, plan for regular reviews, real cloud testing, and scheduled audits as business teams and data grow. As the organization evolves, revisit your RLS because yesterday's setup won't guard today's data. This mindset is where real Microsoft data security begins.